Welcome back, everybody. Ready for another deep dive?
Absolutely. Always ready to explore something new.
Well, today we're going way back, and surprisingly, also into the future.
Sounds intriguing. What's the topic?
Navigation by the stars. You know, like ancient mariners.
Celestial navigation. But with a modern twist, I'm guessing.
Exactly. We've got some research on, well, it's actually tracking meteoroids, but...
But it uses the same principles, I bet. The stars as a reference point.
And then there's this study on drones. They're actually teaching drones to navigate using starlight.
Now that's impressive. I can't wait to hear more about that.
Me too. But first, let's set the scene. For centuries, sailors crossed oceans using only the stars. Well, how'd they even do that?
It's pretty amazing when you think about it. They use a tool called a sextant. It's like a telescope with a protractor built in.
A protractor? So they were measuring angles?
Yep. They'd align the sextant with the star and measure its angle above the horizon. That gave them their latitude.
Latitude. So how far north or south they were?
Exactly. But of course, you need more than just latitude to know where you are.
Right. You need longitude, too. East or west. So how did they figure that out?
That's where things get really tricky. They needed to know the exact time, but not just any time, the time back at some reference point.
Like Greenwich, England, where the prime meridian is.
Exactly. And to do that, they had these incredibly accurate clocks called chronometers.
And by comparing the time on the chronometer with the position of the sun or stars.
They could calculate their longitude. It was complex, required tons of skill and knowledge.
It's amazing how they navigated the world without any of our modern tech.
It really is. But what's fascinating is how this ancient art is now making a comeback in all sorts of modern applications.
You mentioned meteoroid tracking earlier. What's that about?
There's this project called FRIPON, stands for Fireball Recovery and Interplanetary Observation Network.
Catchy name.
Right? So it's this network of, get this, 150 cameras and 25 radio receivers across Western Europe and Canada.
Wow, that's a lot of equipment. What are they looking at?
Not ships this time, but meteoroids as they enter the Earth's atmosphere.
So they're like constantly watching the skies for these, what, shooting stars?
Yeah, basically. And the really cool thing about FRIPON is that it's so dense, the network, that if one camera picks up a meteoroid,
the other cameras can zero in on it too.
Precisely. They get multiple angles, calculate the trajectory really accurately, and sometimes they can even predict where the fragments might land.
Wow. And then they go and collect them.
Yeah. There have been cases where they've recovered meteorites within hours of them hitting the ground.
That must be so cool, holding a piece of space rock that just fell to Earth. But, I imagine it must be hard to track these meteoroids.
Oh, definitely. I mean, cloud cover and daylight are obvious obstacles.
Right, you can't see much through clouds.
And even on a clear night, if a meteoroid is smaller than, say, a centimeter.
They're pretty much impossible to spot.
Pretty much. And then there's the whole issue of calculating their trajectory.
Because they're moving so fast.
Incredibly fast. And they're slowing down and changing shape as they burn up in the atmosphere, so it's not a simple calculation.
I bet. But, I'm curious. Why go through all that trouble to track these things? What's the scientific value?
Well, each meteorite is like a little time capsule from the early solar system.
Oh, so by studying them.
We can learn about the composition of planets and asteroids, the processes that formed our solar system, all sorts of things. It's really fascinating.
It is. Okay, so we've got ancient mariners using the stars to navigate the seas, and now scientists using them to track space rocks. That's pretty amazing. But you mentioned something about drones using starlight too, right?
Right, and that's where we really start to see the potential of celestial navigation in the modern world. Drones using starlight for navigation. That sounds straight out of a sci-fi movie.
I know, right? But it's actually happening. Researchers are looking at it as a backup system, especially in places where GPS might not work.
That makes sense. GPS isn't always reliable. But how do they get a drone to navigate using something as, well, distant as stars?
That's the challenge. Apparently, the sensors on these cheap, lightweight drones aren't that accurate.
So even a tiny error in measuring a star's position could send the drone way off course.
Exactly. So they've come up with this clever workaround. They fly the drone in a circle.
A circle? Why a circle?
Well, by constantly moving in a circle, they can average out the sensor errors. It's like,
It's like shaking a measuring cup to level off the flour when you're baking.
yeah, kind of, and it seems to work. Even with those inaccurate sensors, they've been able to get a drone within 4 kilometers of its actual location.
4 kilometers? That's not bad, considering. But flying in circles all the time seems a bit limiting, doesn't it?
It does. The That's why researchers are working on better algorithms, ones that can predict the drone's movements and adjust for the sensor errors in real time.
So it's not just about seeing the stars, it's about understanding how the drone is moving in relation to them.
Right. It's all about combining that star data with information about the drone's acceleration, its rotation, even things like wind conditions.
It sounds incredibly complex, but if they can crack it, the potential for drones is huge.
Okay, so we've talked a lot about the technology side of things, but let's not forget the science. What are we actually learning from all this meteoroid tracking with Fripon?
You mean besides the fact that it's super cool to collect space rocks?
Yeah, besides that, I mean, what are the scientific insights?
Well, I remember you saying that meteorites are like time capsules from the early solar system.
Exactly. By studying their trajectories and composition, we can learn about where they came from, what they're made of.
And that tells us about how the solar system formed, right?
Precisely. It helps us understand the distribution of materials in the early solar system, the processes that led to the formation of planets, all that good stuff.
Wow. So each meteorite is like a little piece of the puzzle of our cosmic origins.
You got it. And it's not just about our solar system either. By analyzing the chemical makeup of meteorites, scientists can even learn about conditions in the early universe.
The early universe, that's going way, way back. I know. Billions of years. It's mind-blowing to think that these little rocks hold clues about the very beginning of everything. And speaking of going way back, you mentioned earlier the possibility of meteorites coming from outside our solar system.
Yeah. Interstellar meteoroids, those are the ones that didn't form here, right? They came from somewhere else entirely.
Right. They originated in other star systems and somehow ended up here.
That's incredible. What can we learn from them?
Well, they offer us a glimpse into the diversity of planetary systems out there. By studying their composition, we can get an idea of what planets in other parts of the galaxy are made of. It's like having a sample from a distant world delivered right to our doorstep.
It's like interstellar mail. So cool. But okay, shifting gears a bit here. We've talked about the science, the tech, the potential. But what about the people involved in all this? What kind of skills do you need to do this kind of work, this modern celestial navigation stuff?
That's a great question. It's really a blend of the old and the new. On one hand, you need a strong understanding of math, physics, computer science.
The technical side of things.
Exactly. But at the same time, you also need that traditional knowledge of the night sky, being able to identify constellations, understanding how the stars move.
So you can't just rely on computers and algorithms. You still need to be able to look up and actually understand what you're seeing.
Absolutely. It's that combination of scientific knowledge and that almost, well, poetic appreciation of the cosmos that really makes this field so special. It really is. It's like you said, you need that scientific mind, but also a bit of the poet.
Definitely. Someone who can see both the science and the beauty of it all.
Exactly. Someone who can bridge that gap between, well, the technical and the, I guess, the awe-inspiring.
Yeah, the awe-inspiring. That's a good way to put it. Well, I have to say, after this deep dive, I'm feeling pretty awe-inspired myself. I mean, who knew looking at stars could be so relevant today?
Right. It's not just ancient history. It's cutting-edge science and technology. And who knows what the future holds?
Exactly. What other applications are out there just waiting to be discovered?
Yeah.
If we can track meteoroids, guide drones,
Create super accurate positioning systems.
what's next? Spacecraft navigating by pulsars. Robots exploring alien planets using constellations we don't even know about.
Now that would be something. Imagine a rover on Mars using the Martian night sky to find its way.
It's mind-blowing. But it's not totally out of the realm of possibility, is it? I mean, if we can do it here.
Why not on other planets? It's just a matter of, well, adapting the principles to a different set of stars.
It's amazing to think about. The same stars that guided those ancient sailors across the oceans.
Could one day guide us to new worlds.
It's a pretty powerful thought.
Yeah.
So as we wrap up this deep dive, what's the main takeaway for our listeners? What should they be thinking about when they look up at the night sky?
I think the biggest takeaway is that the stars are more than just pretty lights. They're a source of knowledge, a guide, a connection to something much bigger than ourselves.
I like that. They're a connection to something bigger. Well said. And on that note, I think it's time to wrap up this episode.
Until next time.
Keep exploring, keep looking up, and who knows what you might discover out there in the vastness of space. Thanks for joining us for another deep dive.